Video number 147. Function values at points in space. 6 trig values. Here we go. First of all, from basic geometry, most students probably know this. However, they've seen the abbreviations. These are abbreviations for fuller words. Sine, S-I-N-E, cosine, just as it's spelled out here. The definition has to do with the relationship amongst the sides dealing with an angle of a right triangle. So if this was a right angle here, we could then say angle A has a sine value of whatever this side is divided by that. So you could tell already that the tall triangles would have a large sine value, and the smaller triangles, or the shorter triangles, would have a smaller sine value of that particular angle. So there's relationships that occur over the course of specific angles. Now, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Now, cosecant's the inverse of sine, so therefore it's going to be hypotenuse over opposite. Secant is going to be the inverse of cosine, so it's adjacent over hypotenuse. And cotangent's obviously the inverse of tangent, so therefore it's going to be adjacent over opposite rather than opposite over adjacent. Now, what we probably do want to do at some point, let's do this first one here together, but we're going to want to take a look at the unit circle here on this page. We're going to create it ourselves here in just a moment. Let's go ahead and take a look at this first example. So it says, find the 6 basic trig values of the angle formed by the point 24, -7. Well, that takes us, if you go to the right 24 and down 7, that takes you here. Well, this distance is 24. This distance is 7. It's on the negative side. And that would be our right angle. This angle here, we'll call it theta. That would be referred to as what's called a reference angle. And the reference angle is formed by drawing directly up to the x-axis or down to the x-axis. So you're always going to have this right angle that's formed, so therefore you're always going to have a right triangle. Okay? And that's what trigonometry is. Trigonometry, the definition of it is basically the metrics of triangles, or the metrics of angles. Right triangle trigonometry is the most popular form, and that's what we're looking at here. Let's continue. Sine is opposite over hypotenuse. Well, we need to know this hypotenuse value. Well, guess what? You can do the Pythagorean theorem. So we're going to do -7 squared plus 24 squared equals c squared. Upon doing this, we get c is 25. Now, you know what? Notice what's pretty cool about this is that this is a negative number here. Notice how when you throw it into the Pythagorean theorem, it's always going to come out as a positive. This would have been 49 plus 576. And we eventually would have gotten 625 and then did the square root and got 25. But notice here, it doesn't matter where you are, the hypotenuse will always be positive. So remember that. Okay? So sine is definitely -7 over 25. Cosine is 24 over 25. Tangent is opposite over adjacent, so -7 over 24. Cosecant. Cosecant is going to be the inverse of sine. So instead of -7 25ths, it'll be -25 sevenths. Secant, 25 24ths. Cotangent, -24 sevenths. Okay, notice here as well, I want to point this out. Here's where you step over the line. You go from being a geometry person to a trigonometry person, and this is the first step right here. Up until this point, we've always thought about tangent as being opposite over adjacent. But think about this. Isn't tangent also sine over cosine? Think about that. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And this is equal to tangent. Is it equal to tangent is the question. And the answer is yes. The hypotenuses will cancel out. Look what you get. Opposite over adjacent. There you go. There you have it. There's the verdict. So tangent can be thought of as opposite over adjacent for geometry people. But if you want to start understanding trigonometry, you're going to start thinking about each of these trig functions in different ways. This is the first step. Here we go. Next one. Actually, yeah. No, let's continue here. Let's continue here. -3, -4. We're going to go to the left. -3. We're going to go down 4. Puts us here. Reference angle. Bam. -3, -4. Sine. Well, hypotenuse is 5 when you do the Pythagorean theorem. Sine is what? -4/5 or -3/5? That's always the reference angle, so therefore -4/5. Cosine, -3/5. Tangent, ready? It's going to be 4/3, because it's going to be -4 over -3. Sine over cosine. Just take the numerators and divide those down. Cosecant, the inverse, it'll be -5/4. Secant, -5/3. Cotangent, 3/4. All right, now, before we do this next one, we need to take a look at the reference, or I'm sorry, the unit circle. So we're going to go ahead and draw the circle as best I can. Draw the circle first, usually easier. That's why it's tougher here. All right, we're going to call this point here, because it's a reference circle, 1, 0. This point here, 0, 1. This point here, -1, 0. That point there, 0, -1. This is your creation of the reference, or the unit circle. The unit circle has a radius of 1. Now watch this, guys. Any random point over here, which would create any of these angles, any of these reference angles, it's always going to have a positive x, right? Positive x, positive y. So therefore, sine is positive. Cosine, positive. Tangent, positive. All right? Tangent will be positive because you're going to do a positive divided by positive, which is positive, sine over cosine. Now notice how, remember what you're doing with sine. Sine would be what? The y over the hypotenuse. So the sine goes with the y's, the cosine goes with the x's, because this will be the adjacent side. Think about this angle over here. When you go over here like this, you're going to draw upwards. That's going to be your y, that's going to be your x. Whew. Opposite over hypotenuse. Sine is with the y's, cosine is with the x's. Let's go over here. What's going on in this quadrant? This is quadrant 1. Quadrant 2, -x, positive y. All right? Sine, cosine, and tangent. What's sine? Deals with the y's. It's positive. Cosine, negative. Tangent's going to be negative because it's sine divided by cosine. See that? It's already helping already. Over here, what do you got? -x, -y, right? How do you get to any of these points? You got to go left, and then down. So negative, negative. Sine is negative. Cosine is negative. Tangent is positive. Negative divided by negative. All right, what about over here? Positive x, negative y. Sine is negative. Cosine is positive. Tangent, therefore, is negative. All right? So what we're going to do here, in order to deal with this problem, let's first of all go ahead and graph the situation. 0, -7 is right here. Now, they're not asking us to find... What they want us to find is the basic trig values for the angle formed. Well, what is the angle? What is theta here? How much is theta? 270. What they're asking us to do is find sine 270. And in order to do that, we're not even going to use this. We're going to use the unit circle. And you're only going to go to this one spot. I drew a heart. There you go. You're going to draw this right here. It's going to be what? 0, -1. Okay? Alphabet. Oh, that's right. That's right. We forgot to tell you. All right. If you go over here, there's more patterns. There's more patterns here. Watch this. We did all the 4 quadrants. Now, what about on the quadrant? What about sine of 90? You don't need to run to the calculator anymore. Watch this.